We are looking at the differentiation of a functions part two. We are looking at a series of questions. Okay, let's look at the question one. Differentiate with respect to x. Okay, we have number one, ddx of sine square s squared plus 1. Yeah, so this will be equal to, you look at this, the sine, which is sine squared. So differentiate that will be 2, will come to the front, sine 2 minus 1, that's power 1 of the function, okay, and then times the derivative of sine, which will be cos of the function, s squared plus 1, and finally times the derivative of that function, s squared plus 1, and that will give you the derivative of this one is what? Is 2x. So 2x times 2, so that's 4x sine s squared plus 1 cos s squared plus 1. So that's that on that question. If you want to use more explanatory way, let's call the question, let's call it y, call the question y, sine squared s squared plus 1, which this one I'll be written as what? Sine s squared plus 1 to power 2. Okay, so we can write this as y equal to v squared, where v, where my v is what? Sine, where my v is where v is equal to sine w, and my w is equal to s squared plus 1. Okay, so this is y is a function of y is a function of w, and w is a function of x. So this is a function of functions, and this is a function of functions of functions. So then we can get the y, the x, which will be equal to what do we have here? So that will be what? That will be the y dx, what we're looking for. Okay, so we are looking for. So then we have the y, the v, which is equal to what? 2v. Then we can also have, we can have the v, the w, which is cos w, and we can also have the x, the w, we can have the w, the x, which is equal to 2x. Okay, then finally my dy, the x will be equal to dy, the v times the v, the w times the w, the x. So just know that where you stop here is where it will start at the top there. When you stop here, it will continue at the top there. Okay, so let's substitute all what that. We substitute that. We have we're going to have the y to v is 2, is 2v. Okay, then the v, the w is cos w, and then the w, the x is 2x. So I can see these 2 times 2x, that's 4x. And my v is what? Sine. My w is what? Replace that w there, sine w. So w is s squared plus 1. And then cos w, cos w, that's what? S squared plus 1. So that's that on that question. So somebody that use this method and somebody that use this method, they get the same marks. Okay, but the thing is that you must get it right here. Okay, question 2. Question 2 is a product rule. We're having, let's call it y, call the question y. So let's y be equal to x plus 1, 2x minus 1 power 4. So your this will be product rule, y prime is a product rule. you take one constant, okay, then you differentiate the other one. That will be dx of this 2x minus 1 4. Okay, then plus this one here, which you are differentiating, you take it constants, okay, then you differentiate this one. That will be what? X what? X plus 1 prime. Prime means ddx. You're differentiating it. Okay? So you don't want to put prime, just say ddx of this. So that will be equal to f plus 1. Let's differentiate this one. The 4 will come to the front. 4, then 2x minus 1. 4 minus 1 power 3. Okay, then times the derivative of this base times 2. Okay, then plus 2x minus 1 power 4. The derivative of this one is 1. Okay, so finally 4 times 2, that's 8, into bracket x plus 1 into bracket 2x minus 1 power 3, then plus 2x minus 1 power 4. So that is that on that question. That's that on that question. Then I will go to question 3. I'll go to question 3. Then I will not waste the time there. ddx of tan cube of the function. So this will be this way. This will be 3. Differentiate that. That will be 3 tan 2 minus 1 square of the function. I mean the angle. Okay. Then times derivative of tan. If you differentiate tan will give you sec square. Sec square the function. Okay. And finally, times derivative of that function inside times 3. So the answer is what? 9 tan square 3x minus 4, and then sec square 3x minus 4. So that is that on that. You just have to confirm that the derivative of tangent is sec square. Okay, and that's that. That's that. Differentiate your tan. Okay, that will be 3 times 3 minus 1 tan square the function. Okay, then times the derivative of tangent, which is sec square the function, and then times the derivative of the function, which is 3. So, and that's that. So I'll go to question 4. I'll go to question 4, and if you like, you can use my longer, all this my story here, and use it also for it. Okay, ddx of cos x all over 1 plus sin x power 3. Okay, so this will be 3, the expression cos x 1 plus sin x 3 minus 1, that's power 2, then times the derivative of that, of this, of the base. No, we have the base, we have the power of the base. So derivative of times this 1 plus sin x. Okay. So, and that will give me 3. Okay, I think we can expand this one, or we should leave it for now. Okay, let's leave it for now. So this will be equal to cos x over 1 plus sin x square. So let's now do the quotient rule for this one. It's a fraction, so we use quotient rule. So that will be equal to 1 plus sin x v square. That's v square times the derivative v. V will be here times the derivative of the numerator. That's minus sin x, and then minus u cos x. Okay, times the derivative of the denominator, which is what? Which is cos x. Okay. Then we're going to have now, can we open this one? There will be 3. This will be cos square x, because this power 2 will affect the numerator and will affect the denominator. So all over 1 plus sin x or square, and then times, okay, if you don't want to use, I can use brackets. So that will be, open this one, that will be minus sin x this one times this one, that's minus sine square x. And this will give us cos x minus cos square x all over 1 plus sine x all square. Okay, so with this now, I'm having 3 cos square x all over 1 plus sine x all square. Then times, I think these two, you can take the minus out there. Okay, open your brackets. Open your brackets. Forget that times, open brackets. That will be minus sine x. Minus is here. Minus is here. You can take it out. Then you have sine square x plus cos square x all over 1 plus what? Sine x all square. Okay? And that will give me, this will be 1. This will be equal to 1. Okay? Then we have 3 cos square x all over 1 plus sine x all square. Okay? Then this will be equal to this will be minus sine x minus 1. So we can also take minus out there. So that will be equal to what? That will be equal to, if you take minus out, then we have 1 minus times minus plus sine x. If you take minus out, okay, open your brackets, plus sine x all over 1 plus sine x all square. Okay? This one plus this one is 1. So I'm having minus sine x minus 1. So what I did now is factorize the negative, take minus out. Okay, if you take minus out from here, you have minus 1 here. So we have the 1, and then minus and minus, that's plus sine x. Okay, so this one we cancel, to remain 1 here. So you now have your final answer. You have your final answer as the negative here times 1 here. That's minus 3 cos square x, minus 3 cos square x. Okay, what again? Then over 1 plus sine x power 3. So that's the final answer. The negative here times this one. Okay, then we have power 2 here, we have power 1 here. Okay, so that will be power 3. So that's the answer to that. And that will take us to the last question. Okay. That will take us to the last question. The thing is just that you just have to be focused on what you are doing. Don't allow distraction. You get it. Okay, this is quotient 2. Apply your quotient 2. Okay, so that's that. ddx, want to find the derivative of that of sec cube. The function tan square 3x. Okay, so I'm not going to use alphabet to represent anything here. I'm going to do it straight away. So, so this will be equal to 3 here. That will be 3 sec square. The function tan square 3x. Okay, then times derivative of sec, which is what? Sec tan sec, the function, sec tan, that's a over sec, the function, tan square 3x. Okay, and then times what again? The ddx of the angle itself, ddx over tan square 3x. Okay, ddx of tan square 3x. So I can do that ddx somewhere. Let's get the ddx of tan square 3x. Okay, so that will be equal to the 2 go to the front. That will be 2 minus 1 power 1. Okay, 2 tan the function, the angle. Okay, and then times the derivative of tan, which is what? Sec square, the function, and finally times the angle here, times the derivative of this angle here, times 3. Okay, and that will give me 6 tan 3x sec square 3x. Okay, then let's substitute and make it a single line. So the answer will be equal to 3 sec Sec is here. We have two of these. Okay, we have two of these. Okay, 6 is here. 6 times 3, that's 18. But let's just leave that one for now. Sec is here, sec square, and 1 is here, and the same function inside, the same angle. So that will be sec cube, the angle, 3x, sec cube, the angle. Okay, here we have tan, in the bracket, tan square 3x, and then times what we have here, what we got here, the root of this one, which is what? 6. This we cannot contain it, times 6 times 3x sec square 3x. The final answer will just be equal to 3 times 6, that's 18, sec cube, the function, 3x, and then followed by tan, the function, and then sec tan. I'm trying to have a single line. I want to have a single line there. I want to have a single line. So this will be equal to 18, 6 times 3, 18, sec cube, the function, tan, the function, square 3x, then followed by tan 3x sec square 3x. So that's the answer to that problem. That's the answer to that problem. Okay. The only thing I can do, just to quickly recap it, is very simple. You start from the sec, that's the root of the function. Okay, so 3 will come to the front. Okay, sec 3 minus 1, sec square, the function. Then the next question is, what is the derivative of sec, which is sec tan. Okay, derivative of, if you are talking of derivative of dds of sec x, will give you sec x tan x. Okay, but our function here, you have to also consider the function. So that will be sec, the function, okay, the angle, and then tan, the angle. And the next thing is the derivative of the function itself. That's tan squared 3x. Okay, and we went here to explain the derivative of dds of what? Dds of tan squared 3x, which is what? 2 will go to the front, and that will be 2 tan, okay, 2 minus 1, that's power 1, okay, the function 3x times derivative of tan, which is what? Sec squared, the function 3x, and then times, finally, times derivative of this function 3x, which is 3, and that will give you this one and this one, that's 6. Okay, 6 times 3x sec squared 3x. Okay, then what we need to do now is to come back here and put that differentiation there. Okay, then finally multiply everything together, this one times this one, that's 18, and don't forget you have sec square here, you have 1 here, making sec cube of the function, because the function must be the same thing before you can multiply. The function must be the same before you can multiply. Okay, I mean the angle must be the same. So we have that. Then tan the angle, okay, tan the angle, and that's this tan. The tan here, you can't multiply it because the angle is not the same. The function inside the tan is not the same. So that will be tan, the angle, the function, and then followed by tan 3x, sec squared 3x. So that's that question. So your mind must be there. You must remain focused so that you don't make mistakes. Okay. So that's on that question. Okay. Please, if you are new on this channel, hit that subscription bell, notification bell, so that as we upload, you get notified. Okay. If you are new